Okay, this is going to be a review on ecology for our ecology unit, and you're going to find this in somewhere in your unit packets. And I'm going to start it, and there'll be some time where I'll have you pause, and there'll be some other times where I'll put up some questions, and then we'll discuss them in class so that I know you kind of went over this. So let's start. I'm going to start on the first slide here, and most of it will go pretty quickly. And you see some of the learning targets that you can check from your learning targets on the unit packet. And here's some of the terms that we've gone over already. And these are some of the good vocabulary words. And I'll remind you again that when we talk about ecology, we're talking about organisms and how they interact with each other and their environment. And that's a little different than a habitat, because a habitat is just kind of the place where an organism lives. So a habitat could be within an ecosystem. And we've discussed biotic and abiotic factors, some of the living things that influence organisms, and then some of the non-living, like the conditions of the environment that affect species in an ecosystem. And the last thing that I went over already in class has been that we kind of start when we talk about populations of things in ecosystems, populations of organisms. We start at the individual, and then if you have individuals of the same species, a group of them, that's called a population. And if you have different populations of different species of living things, we call that communities. And when you put those different communities together, you make an ecosystem. And that includes all the abiotic and biotic factors. And then put it together to make the Earth. We call that the biosphere. And that's the broadest, or what is the biggest level. When we talk about things about abiotic factors that influence organisms, we're talking about things like temperature differences, soil, sunlight, water amount that's in the soil. Think of a desert not having as much water. And we need water. You're nice 70% water, and organisms have to have a way to keep water and then also get rid of water to cool off or when they have extra water. And wind is another good one too. That influences whether certain plants or animals can be in a certain environment. And then we have something that are called severe disturbances. You guys probably know them more as volcanoes or fires, hurricanes, storms, things like that. Anything that might influence the ecosystem of a particular organism. Okay, I'm going to ask you now to take a second, and I want you to try to do the concept check. It looks something like this. And if you could take a second and do those, we'll go over them when we get to class. So we're going to kind of go back while you're maybe pausing this and trying that out. And I'm going to skip now past those concept checks, and we're going to move on a little bit to discussing how you can measure the population of a particular organism. And that's where we're going to start right now. So let's start here. You're going to go a couple slides down. We're going to kind of look at geographic distribution, how organisms are distributed around the world, and we tend to refer that as density, how many individuals there are for a certain area. And then we use a term called growth rate that obviously is looking at a combination of how many births there are, how many deaths there are, how many people immigrate or emigrate from a certain ecosystem. And then age too. These are all very important characteristics of a population that will influence how it survives. To measure the population of a certain organism, you could do all sorts of things, but you basically want to look at how many organisms there are per certain area that you're looking at. One way to do that is to put down an actual device called a quadrat, which is a kind of a squarish object that we're not going to use in class, but it basically allows you to count within a certain area the number of individuals, and you then take an average for different locations. Another one is called indirect counting. That is where you don't actually see the organism, but you look at tracks or maybe nests, or maybe there's holes or burrows in the ground. And the last one is called a mark and recapture, which is where you actually trap the animal, mark them, and then you come back and count them later to see which ones are still there. And again, now you're going to get to 35.1. And if you can go and do those, I'm kind of showing you a little bit that I have an answer key for that. And let's go to that and let you take a second to do that. So that's going to be 35.2. So I'll wait for you to do that. You're looking at these right here, 35.1. These are all references to the current book. And the last thing that I'm going to discuss for you guys is something we actually already went over as well. So this should be a review. And we talked about exponential growth, and we've talked about linear growth. So you're going to go to this slide in yours, and then I'll put it back onto my answer key for you. And I'll start that in a second here for you. So you guys know this already, but we look at number of births, we look at number of deaths, and then we look at number of individuals that go in or out of a population just from wandering or traveling. And exponential growth, as you know, is the population number increasing by a higher number every single time interval. And we did the money activity for that. So I'll give you this example of a graph here. You don't have to really look at the actual information there. It's just showing you that if you look at bacteria, for example, growing over time, it grows pretty slowly in exponential growth, but then at a certain point, it starts to, because it's increasing by a higher number each time interval, you see a very steep, what we call a J-curve for an exponential curve. And I can let you read that when you can pause this if you want to read that so you can see how we plotted. It's just a sample graph. So the things that we call, that limit whether a population can grow are called limiting factors. We're going to be doing those we haven't done those yet as of the making of this video, but we will be doing that. And space is one of the limiting factors, how much food or water, how much disease there is. So remember, I did tell you that exponential growth tends to be the normal. If you read this kind of middle part here, exponential growth tends to be normal, but it doesn't continue forever because populations are going to have to get slowed down or they would overpopulate, compete with each other, or hurt other organisms. And so space and food and water and shelter and disease, all of these are things that limit the population growth. And we call the total amount that an ecosystem can hold of a certain organism, that's called its carrying capacity. And I believe we've talked about that word too. And so normally in a population, it starts to look something like this, which we call an S-curve, where it grows for a while, then it levels off. And I'll show you that right here. After it grows for a while, it levels off. If it kept going and going and going, there would be a lot more problems with competition and predators and prey. And then there's some 35.2 concept check questions for you to check on those. And you can kind of see the answers, but we'll go over those more in class. So, I hope you enjoyed this, and I'll see you guys in class. Thanks a lot. Bye.